So there is a linked answer question here. The data given is given below are two regular languages, that is L1 is equal to W such that W in 0 comma 1 whole closure and each string starts with 0. Language L2 is W such that W in 0 comma 1 whole star and each string ends with 1. Question number 1 on this data is, which one of the following is the intersection of the two languages L1 and L2? So option A here, option A is W such that W belongs to 0 comma 1 whole closure and each string should start and end with either 0 or 1. Option B, W such that W belongs to 0 comma 1 whole star and each string should start and end with different symbols. Option C, W such that W belongs to 0 comma 1 whole star and each string should start and end with the same symbols. Option D, W such that W belongs to 0 comma 1 whole closure and each string should start with 0 and ends with 1. So here we need to find out the intersection. So the given languages are, L1 is each string starts with 0. That means 0 followed by, we can have any combination of zeros and ones. So this is L1. L2 is W says that W in 0 comma 1 whole star, each string ends with 1. That means any combination of zeros and ones, it has to end with 1. That means if you want to have an intersection that is common strings, if any string you take which starts with 0 and end with 1, that will be a common. 0, 0 plus 1 whole star and 1. So this is the regular expression which is intersection of L1 and L2. Option A is given as each string should start and end with either 0 or 1. This is wrong because it has to start with 0 and end with 1. Option B, W belongs to 0 comma 1 whole star, each string should start and end with different symbols. Different symbols means this will support 1 followed by 1 0 0. So this is start with 1, end with 0. Start and end with different symbols. But 1 1 0 0 is not a common string. That is not available in, because it has to start with 0. That's why option B is wrong. W belongs to 0 comma 1 whole star. Each string should start and end with the same symbol. So if you start with 0, end with 0. If you start with 1, end with 1. That is not possible because we are starting with 0 and ending with 1. So C is wrong. D, each string should start with 0 and ends with 1. That is what 0, 0 plus 1 whole closure and 1. This is the intersection regular expression. Option D is the correct option. So there is, based on this answer, there is one more question, that is the linked question. So the linked question is, what is the number of non-final states in the minimized DFA accepting the correct language above? What is the correct language we got? A string starts with 0 and ends with 1. So 0, 0 plus 1 whole star 1. So for this, the DFA requires how many states? From that, we require to have the non-final state. Number of non-final states in the minimized DFA. So here, to accept this, we can have the DFA like this. So we have to start with 0, Q1 and 1. This is final state, which is Q2. After 1, we can have any number of ones because it end with 1. The 0 of Q2 we can take to Q0 and the 1 of Q0 because we should not start with 1. And Q1 1 can be taken as self loop. Q1 1 is already there. Q1 0 we can take as a self loop, and we can take a dead state, that is Q0 on 1 will be sent. Dead on 0 is dead, 1 is dead. Total 4 states, out of which we are having 3 states as non-final states. So we are having 4 states total, out of which we have 3 non-final states. A dead state also must be considered in the number of states, which is a non-final state actually. So 3 states. Option B is the right option here.